Hello, physics geniuses. Let's learn about the moment of inertia today. Let's look at a few examples. It can be experienced very easily. For example, hold your phone charger at the part where it plugs into your phone and spin it in a circle. As we see, it's moving in a very large circle with a larger diameter, but kind of slow. In this second example, I'm holding the charger at the halfway point, and the speed that it's spinning at is much faster than the first example. This is due to the smaller diameter of the spin. Let's break down what just happened in a conceptual manner. The moment of inertia is defined as a quantity expressing a body's tendency to resist angular acceleration. It is the sum of the products of the mass of each particle in the body with the square of its distance from the axis of rotation. It relates the sum of torques put on an object in a given sense to the object's angular acceleration in that sense. It is sometimes likened to mass. However, moment of inertia is a concept of rotational motion instead of linear motion. And the ideal moment of inertia for an object moving rotationally is zero. This guarantees that the object will move more efficiently. For example, think of a football. If the football is ducked, then it will not go as far, nor will it travel as fast or as accurately compared to a football which is thrown in a spiral. That last example is the key difference in the football game of Tom Brady and the football game of Brock Osweiler. Tom Brady throws a good spiral and he's a much better player because he can throw it accurately, and Brock Osweiler isn't. Let's look at another example of this. If I spin on the physics chair and my center of gravity is distributed not directly over the axis of rotation in the center of the chair, but over a larger radius, the angular velocity is much slower. Additionally, you might not be able to see in this video, but I'm having a hard time bouncing when I'm leaning backwards. But if I spin in the chair and I'm tucked into a ball, my center of gravity is distributed almost directly over the axis of rotation, and I accelerate angularly, and my rotation is more efficient. I'm spinning with a greater velocity, and I almost fall off a couple of times, just because it is so fast sitting in that chair. It doesn't look fast in the video, but you kind of have to be there to figure it out.
Keep going, Melania, keep going. Spin faster, spin faster.
Oh, God, no.
Melania, I think we have enough video, man.
Yeah, that's probably enough video. Let's do some math problems. First, we need to find my mass. We know my force and we know the acceleration that I experience when I'm standing still. So it follows that my mass is about 80 kilograms or so. So to find the moment of inertia, we have to estimate that the radius of my first spin was 2 meters and the radius of my second spin was half of a meter. We know that my mass is a little bit under 80 kilograms. Remember the equation that we talked about earlier, which says the moment of inertia is equal to the mass times the radius squared? Well, now that we know my radius and we know my mass, we can do a little bit of a calculation and find out the moment of inertia for the first spin I experienced was 317 kilograms meters squared. We can do the same thing that we just did with the equation, but with these second numbers. The radius, which is 0.5 meters, and the same mass. And there we get that my moment of inertia in the second spin was a little bit over 19 kilograms meters squared. We've talked about previously that the best moment of inertia for objects moving rotationally is closer to zero. So therefore we can tell that the better moment of inertia that I had, the one where I'm spinning faster and more efficiently, is the second one. It's also said that golf clubs that have a higher moment of inertia have something called forgiveness, which means that it's harder to just mess up a shot completely bad. This is because these golf clubs with the higher forgiveness and the higher moment of inertia have the same mass as another golf club, but it has a larger area on the face of the club which can strike the ball, meaning that you can hit the ball in more places. So the sweet spot that is the best for hitting the ball is simply a lot bigger than other clubs. All right, it's been great. Thanks for watching. I hope y'all learned a lot, and y'all are geniuses.